unpacked for us, and right at the end we do see that flag. The tab key will save you years. Hi friends, welcome back to the channel. Let's lift some weights virtually. If you're new here, my name's Ash, I'm 27, I'm a cybersecurity enthusiast, and on this channel we go over Pico CTF and we train in the gymnasium together. On today's video we are going to be doing exactly that. We're going to be going over a few categories of CTFs, so we're going to practice some skills, getting ready for the current event. Pico CTF 2023 is actually live right now. For notes on the challenges, see hack notes down below in the description, and while you're in the description you can find timestamps and links to anything else that you need. All right, let's get started. So we've navigated to play.picoctf.org and we've clicked on practice. So for Pico CTF in its current state, there are 6 different categories. We're going to be going over 3 of them in this video. So let's start off here with a easy 20 points called Get Ahead. So let's read our description. We've got find the flag being held on this server to get ahead of the competition. So let's go ahead and copy this link. We're going to be using Burp Suite. Next, start, and on the target sitemap we're just going to go open browser. So the cool thing about this browser, it is connected to Burp Suite directly. Holy, that is very red. That honestly hurts my eyes a little. So if we go back to our sitemap, we can see that Burp is starting to pick up some information. So what we can do is we can right click this and we can send it to the repeater, and this is where we can start to repeat that request. So if we select send, we can see the HTML output of the page that we see in the browser. And if we quickly go back to this horrid red and we hit Control U, that'll bring up the view source. So it's usually a good idea to have a quick look through there, try and get an understanding of what the web app is doing. Currently, all we see it does is there are 2 buttons. Both of them just go back to index.php, and there's a method get and there's a method post. And as we can see, by selecting the buttons, it'll just change the background color. Now we have a couple of hints. If we look at our title, we've got Get Ahead, and notice that they're capitalized, sort of hinting to where we want to go. Now, as we saw in our view source, we do have a method of get. So it's something to do with this get and post method thing. So if we flick back to Burp Suite, the head are these lines of information in the beginning that we see. These are headers. These are what's packed in the beginning that includes different information. So it's a bit small, but we can see here the host, which is like the domain and the port number that we're connecting to. We've got other bits of information like the user agent, so like what browser we're using. So if we focus on the very first bit of text on line 1, and let's actually take a moment to sort of look up what these are. If we go over to the developer or the developer docs for MDN or Mozilla, we can go ahead and find HTTP request methods. And like we were looking at, this is the get. So there's a various few request methods that we can use, and one might be standing out to you already, this head. So we can see here that it reads the HTTP head method requests the headers, which is that information that we're looking at, that would be returned if the head requests URL was instead requested with HTTP get method. For example, if a URL might produce a large download, a head request could read its content length header to check the file size without actually downloading the whole file. So there we have a little use case for it. So let's go and actually change this header in our request from get to head and then click send. And in the flag, we have what we're after. Awesome, so let's give that a copy and paste that in. Awesome, so let's go over to our next one called cookies. So who doesn't love cookies? Try to figure out the best one. So give that a copy. We'll go back to our Burp Suite browser and we'll paste that in. So it looks like we've got cookies, we've got a home button, which if we look at the URL where that goes to a reset page. Otherwise, we just have a greeting and then an input. So without doing anything, just hitting search, we've got that doesn't appear like a valid cookie. So interestingly enough, they have actually put some placeholder text for us. So let's go ahead and try that. Okay, that gives us something different. That is a cookie, not very special though. Okay, so we're sort of on the right track. That's taken us to this check page, and we do have this dynamically generated message. It's taken what we put in and it's presented that back to us with I love snickerdoodles. So let's hit right click and inspect. We need to find a little bit of more information. So if we go on the application tab, we can actually see a drop down for the cookies. So if we quickly look up HTTP cookies, we get a good definition here. So a HTTP cookie or web cookie or browser cookie is a simple piece of data that a server sends to a user's web browser. The browser may store the cookie and send it back to the same server with later requests. Typically, an HTTP cookie is used to tell if two requests come from the same browser, keeping a user logged in, for example. It remembers stateful information from the stateless HTTP protocol. And we've got some further examples: session management, personalization. Cool. So that sort of leads us back to where we are. So we understand that this is saved in our browser from the server for specific bits of information. So it looks like that we've got a couple of cookies, some auth name, some base64 encoded information, I assume, not really sure. Then we've got this name cookie. So we can actually go ahead and edit some of these, but the one that really sticks out is this value. So we can sort of play around with it. Can we get anything if we go like -1 and hit refresh? Hey, it didn't like that. So we just got an error, please try again. And then we're back to, so we know that 0 works. Let's get back to where we were, hit search, and then we receive that cookie again. Yum, 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 yum. Man, it is like not letting me change the cookies now. I don't know why. So let's do it another way. So let's go back to Burp Suite, and we can see under the target sitemap, we have a new entry here. So it's the same domain, but we're going to this 27177 port number. So we can see our activity that we've already been doing. So if we go and click on one of these, for example, like the check page, and that was the page that we're on when we were changing things, we can see here in this request, here are again those two cookies represented in the header. So we have that auth name, which looks like encoded information, and then we have this name. So why don't we go right click and send that to the repeater. Let's hit send, and we can see our response, which should be exactly like we were seeing in the browser. I love snickerdoodle. So let's try and change this again. Let's just go 1. All right, so now we have a different output or a different response. This time it says, I love chocolate chips. So there's definitely something that we need to find here by going down this route. And we can confirm that if we go to 2. Okay, we're on the right track. We're getting different information. So there's a number here that we're looking for. We can try something ridiculous like 9,999. So we know by getting that output, which is a not found, that there is a limit. There is a number that we need to find. So let's right click this and send to the intruder. We'll go clear. So we're going to automate this step a little bit. I'm going to highlight that 1, going to select add, and that's going to be like the variable or the payload position that we're going to be changing. So we'll go over to payloads, and I have recently found out there's a numbers. So we can go from 0 and up to say 50, and we'll go 1 digit at a time. And then lastly, on max fraction digits, we can just put 0. So we just want the whole numbers, and then we'll go start attack. So this is called fuzzing. Okay, and then we're going to start seeing that go through all the numbers from 0 up into 50. So let's click on 0 and we'll click response, and then we can sort of select how we want to view our responses. So pretty raw, we can look at hex if you really want to. Otherwise we can see the rendered page, and we can just hit the down arrow and just go through these one by one. And after a little while, as you get to number 18, you will see the flag. So to copy and paste, you can go over to the raw tab, we can highlight that, and we can paste it in and get our flag. All right, let's go on to Inspector. Kishore Balan? I'm so sorry for that pronunciation. I assume is this bug bounty hunter and security analyst. Could be wrong, but they have tipped us off that the following code may need inspection. Whoa. So we have a couple links. Just gonna go copy. Just gonna go back to the Burp Suite browser. We could use the normal one, but we'll just stay with Burp Suite. It looks like we have a pretty standard looking website. Inspect me of what? I made a website. How? I used to make these: HTML, CSS, JS, or JavaScript. So these are 3 most prominent core languages to web design and web development. So even the term inspect is sort of hinting us where we need to go. So it's something that we were already using if we right click and we actually go inspect, or we can go view page source. So if we scroll down, we can see a comment highlighted in green in this case, and we have 1 of 3. So here's the first part of the flag. Cool. So going back to the page, it sort of is showing us where we need to really go next. So if we actually look up on our view source, we've got the links to the other assets. So here is mycss.css. Right click and select that. And this is what gives the styling to the website. So if we scroll down again, we can see a comment right down the bottom. You need CSS to make pretty pages. Here's 2 of 3, and we can copy out that flag. So yeah, then the last one is this JavaScript, and we can see here right under the CSS, myjs.js. And cool, as expected, we can see here another comment with the last part of the flag. So if we put it all all together, slap that in. All right, let's go on to our last web exploitation we'll be doing for this video. We've got scavenger hunt. All we have to go off is the description. There is some interesting information hidden around this site. Can you find it? All right, back to our browser. So similar looking websites, what we just saw in the Spectre challenge. This time, just some boring HTML. Do you like my website? So we'll go onto the what, and we see the same thing. So it's sort of pointing us into the same direction that we were going in. All right, cool. So pretty much the same. I can see the first part of the flag. So let's go over to CSS. While I'm here, I'll open up JS. Cool, scroll down. Alright, there's the second part, easy. And then this time we've got, how can I keep Google from indexing my website? So if we do a little bit of research on how Google indexes websites, we can see here like a page is indexed by Google if it has been visited by a crawler or a Google bot, which analyzes the content and the meaning and then stores it in Google's index. So if we actually click through that, we see that definition again, but we do see something a little bit more interesting. It reads, while most pages are crawled before indexing, Google may also index pages without access in their content. For example, if a page is blocked by a robots.txt. Robots.txt, it's the name of text file that tells search engines which URLs or directories in a site should not be crawled. Kind of interesting when we go back and see how can I keep Google from indexing my site? So if we go back to the home page, most commonly this can be found either in the directory or in another directory, but we can actually just go robots.txt. And there we go. There is the third part. But there's more. I think that this is an Apache server. Can you access the flag? Okay, so we have a couple of bits of information. Apache, so that's number one, we need to figure that out. But notice that access is also capitalized. So this is sort of hinting us to look there. So if we were unfamiliar, Apache is a HTTP server. It's free and open source and cross-platform, and like open source software, it's maintained by a community of developers. So let's try and look a little bit deeper. And after a little bit of searching through the documentation, we can find an interesting but very important file called the HT access file. So this file provides a way to make configuration changes on a per directory basis. A file containing one or more configuration directives is placed in a particular document directory, and the directives apply to that directory and all other subdirectories thereof. So it is exactly how it's written out there. And commonly, we can find that the same root directory. So if we go to the HT access, we can see here the fourth part of our flag, which means that there's still more to go. So we've got another comment here. I love making websites on my Mac. I can store a lot of information there. And again, after a little bit of Googling, we can come across a .ds_store, an Apple Mac OS operating system. The .ds_store is a file that stores custom attributes on its containing folder, such as folder view options, icon positions, and other visual information. Well, this is for Mac, and this has our hint. So let's copy that and paste that in and see if we can find it. Would you look at that? We've got the last bit of the flag. So we'll go ahead and paste that in. Awesome. So that's going to do us for web exploitation. So let's go on to cryptography. So we're going to start off on our easy crypto challenges. And the first one, valued at 10 points, we've got mod 26. So our description reads, cryptography can be easy. Do you know what ROT13 is? So if we give that a quick Google, there is a whole website dedicated to it, but this means rotate by 13 places. Sometimes hyphenated, it's a simple letter substitution cipher. This replaces a letter with the 13th letter in the alphabet. So we have an example here, is to N, B is to O, and we can see here the cipher in use. If hello was run through ROT13, it would come out as such, URYYB. So we can tell that this is definitely a flag by looking at the format. Interestingly enough, ROT13 doesn't include special characters, or I don't think it does, because our curly braces are the same, so it might not use all. Either way, let's give it a copy. And my go-to for this sort of thing is going straight to CyberChef. So we can paste that in. We might get an indication of what it is. Otherwise, we can easily just search for it and drag that over. Great. So let's click copy. We can see our flag and we can paste that in and hit submit. Awesome. So next up, we've got mind your P's and Q's. In RSA, a small e value can be problematic. But what about n? Can you decrypt this? So we have a file. So let's go ahead and right click that and go copy link. So we'll make a folder and we'll download that. We'll then look inside and we see here we've got this values text. So we can confirm that it's text by looking at it through file and we can see that it's ASCII. So let's go ahead and cat that out. So we've got decrypt my super sick RSA. We have this C value, this N value, and this E value. So what the heck is going on? So if we look up RSA cryptography, we'll quickly come across a crypto system. So this is a public key crypto system, and it's widely used for secure data transmission. And it's also one of the oldest. And if we scroll down, we can see this operation. If you're good at math, this might come easier to you. If you're like me and nearly failed math in high school, this is not that easy. So remember that we've been given some values and we're looking for some values. So we've got here the RSA algorithm involves 4 steps: key generation, key distribution, encryption, decryption. A basic principle behind RSA is the observation that it is practical to find 3 very large positive integers, E, D, and N, such that with modular exponentiation for all integers. Okay, so hopefully it's making a little bit more sense. I'll be honest, still a bit shady on the whole thing. So we go down to key generation. Here we can see some letters that might be a bit more interesting. The keys for the RSA algorithm are generated in the following way. Choose 2 large prime numbers, P and Q, starting to understand where mind your P's and Q's come from. Factoring harder, P and Q should be chosen at random, be similar in magnitude but differ in length. Prime integers can be found using this test. P and Q should be kept secret. So compute equals P and Q. So that means N, so this here is equal to P and Q. Does that mean that they're plus together? Is that how it works? Or is it like P up against Q? Okay, so I'll be honest, I don't know how much closer I am to understanding this, but I am closer to finding something to do it for me. So gone ahead and found this RSA CTF tool, which is honestly exactly what we need. We need something to uncipher, but this is much more my style. Looking at a help page and trying to figure out how to use a tool. So if we read how we can use this, we have a mode 1, attack RSA. So we have specify the -- public key, or N and E. Public key, public RSA key to crack. You can import multiple public keys with wildcards, uncipher, cipher message to decrypt, and private, display private RSA key if recovered. So if you scroll down, you can go ahead and follow the instructions there. So I'm just going to CD into my user binaries. I'm going to paste in the git clone here. I'm going to make sure to do it with permissions. Then we're going to see if we've got our dependencies, which we have. We'll go into our directory. We'll use pip as it's a Python script to install any other modules that we need. And then we can just go ahead and use it by going through our user bin directory, and we can see a list of more helpful commands. Now, specifically the ones that actually we want to look at, we've got a -N, which represents the N value, and a -E that represents the E value. And if we go back to our decrypted message in this RSA encryption, we do have those 2, meaning by process of elimination, the last thing that we actually need to decrypt or uncipher is C. So with this thinking, let's hit up arrow. So we're going to run our Python script. We're going to specify this -N, and I'm going to go copy this amount, Control-Shift-C, Control-Shift-V. Then we're going to use the -E that we see up here to specify E. Do the same thing again. And then lastly, there's this uncipher. Uncipher a cipher using commas to separate multiple. So we don't have multiple, we just have 1. So we'll go ahead and Control-Shift-C for C, and then uncipher and paste that in and hit enter. And what do you know, after just a mere second or so, we have our flag. How cool is that? Go ahead, paste that in, and we'll go submit. Okay, last up for this video, we've got forensics. So let's go ahead and do some of the easy challenges in here. First out of the gate, we've got information. Files can always be changed in a secret way. Can you find the flag? So we have a cat.jpg. Let's copy that link. Let's go ahead and download that. Okay, so we have a cat.jpg. So we can run file against it and we can confirm that this is definitely a JPG or a JPEG. So there's a few other ways that we can find out more information about certain files. So one popular one is strings, where we can see just an output of any ASCII characters that we can actually see. And it's good to try and do this and then pipe this through like a pattern matching program like grep to see if we can find anything that matches a certain pattern, which may be the flag. Unfortunately though, there's nothing there. So that's sort of scratches out strings. So another popular tool is called EXIF tool. Now EXIF tool reads and writes meta information in files. Metadata being data about data, all of the who created this image, who owns this image, the details like resolution, all that is metadata. So we can go ahead and just run EXIF data against our image, and here we can see this metadata we're talking about. It includes system level information like permissions and like file size, but we can see other information like copyright notice. Okay, we have picoctf, image width, image height, bits per sample, the actual resolution here, which is the same as the width and height, megapixels. Okay, so we have a lot of things. There's nothing that looks that obvious unless we look again. This license is pretty unusual. This looks just like a random string. Usually a license is like a company or something, or maybe like a particular copyright license. So this is just like a little unusual. So why don't we go ahead and Control-Shift-C this? And for some further inspect, let's go back to CyberChef and paste that in. And what do you know? We have a suggestion. If we click on our little wand, we have base 64. And inside that base 64 is our flag. Awesome, let's paste that in. Cool, so that was a cool one. Let's go on to, I really don't know how to say this. It's a Russian doll. That's what I call them. Marushka doll. I feel like the accent is helping, but it's probably so bad. So these dolls are a set of wooden dolls of decreasing size, placed one inside the other. Yeah, these dolls, Russian dolls. I guess we've just simplified the actual name. I didn't actually know what they were called, but yeah, Russian dolls. So what's the final one? And we have an image. So this is sort of implying we've got some data within data. So let's go ahead and copy this link, and we'll go ahead and grab this JPEG. So we'll run file against it. Interesting. This time we've got PNG image data. I thought that this was a JPEG by our file extension, so that's a little sus. We go and run EXIF tool. It gets even weirder, like now it's just leaving us hanging. Oh, okay, there we go. That took a little while. So something is really up. That took ages. A JPEG, or what sort of looks like is actually a PNG, and it says that it's only 652 kilobytes, but yet it took a while to actually see the data. And if we scroll down, it gets even more unusual. We're seeing lots of information about Apple, and then even more information about LCD colors, and then even this binary data, which we have an option from EXIF tool to go use -B to extract. So this is sort of looking like this whole Russian doll data within data. So if we look up the man page and we search for extract, we do have that -B. So this is possibly one way of extracting out our data, but I do know another way. So there's another forensics tool called Binwalk, which is a tool for searching binary images for embedded files and executable code. Now this is exactly what we need. We have an image with what I think is something else in it, which could be some embedded information. So let's go ahead and use Binwalk and pass through this JPEG, and it does its best job to list out the different sets of information at a binary level. And what do we notice here? Archive data. Okay, super sus. So it looks like there is definitely something here. And if we look up our man page again, there's a -e to automatically extract known file types. So that's super helpful. So let's go ahead and try that. Now, if we list out, we have an underscore dolls.jpg.extracted. So let's go ahead and run tree. That's going to list out everything in the contents that we're looking at. So we see our JPEG, we see that file, but now we see another zip folder, and we see a base images, and we see another JPEG. So if we want to open an image, we can use EOJ, a GNOME image viewer, EOG. So we can go inside there and look at this JPEG, and we have our first Russian doll picture. Okay, so we're on the right track. I didn't even check, but I didn't even check the first JPEG, totally forgot. So we've seen our first one, and now we have the number 2C, so there's our second one. That sort of leaves us over with this zip folder. So we can go ahead and use unzip against that, and we can see here that it's extracted something. So we're on tree again, and it looks like this might actually be the same thing. I think Binwalk's actually already automatically extracted that for us, because I've gone and run that again, and it's just giving me the same thing. So I'm just going to remove that. So then let's focus on this JPEG. So I'm going to try Binwalk again, but this time on our second image. Okay, again, we've got some sort of zipped information, so we can just sort of keep going here. Let's go Binwalk-E, and this time we're going against this second image. So run tree again, and we can see how we're just going deeper and deeper. Binwalk-E, go into extracted, base images, extracted again, base images, and this time we're at the third JPEG. Enter, more zipped, run tree again. All right, we're at the fourth. Let's see how long this goes for. All right, here we are, 4. Wait, that was more zip data. Right at the end, we had that last zip, which it unpacked for us. And right at the end, we do see that flag. The tab key will save you years. So we'll go cat and we'll select enter. And right at the end, there is the flag. Awesome, thanks guys. Well, I'm gonna call it there. I appreciate you watching right up until now. Just a reminder that there is a giveaway going on the channel for the month of March. So if you want a free try Hack Me voucher, go in the description and there's a link to the giveaway. Thank you so much for all of your support on the different videos. I'm trying to collaborate more and I'm trying to do different forms of things, so I do appreciate the love and support coming from you guys. Up on the screen you're going to see a recommendation to my last video, which is me blabbering on about why I'm doing what I'm doing, so if that sort of interests you, go check that out. Otherwise guys, thanks so much and I will catch you in the next one.